Villagioso from the Peer Tutor Society, and I am here to help regarding the topic of minimax and alpha-beta pruning in adversarial games under the course CSINTSY, or Introduction to Intelligent Systems, if I remember correctly. So what are adversarial games? The most basic way to think of adversarial games, think of it as yung mga standard games that we have, the standard two-player board games. Think of it like that. So these are games which have an opponent directly working against you. So the most basic one is a two-player deterministic game. So that means there are two players in the game, and one player can choose to do a move. Not only that, when one player does a move, it is time for the other player to do their move as well afterwards. And usually, yung goals of the two players is directly opposite to that of the opponent. So if one player wants to maximize something, the other player wants to minimize that something. Think of it like that. So examples of these are like tic-tac-toe, chess. So these are the most very common examples of adversarial games, or maybe even two companies trying to maximize their own profits. And when one company maximizes their profits, the other company indirectly gets their profits minimized. Parang ganun. So we assume the players in this game are intelligent agents. So when you say intelligent agents, they are trying to get the best possible outcome for them. So that means they will always choose the decision which will result in their best possible outcome. So think of it, in a game you want to win. So we assume that the players will always choose the best thing that will allow them to win, parang ganun. And these games can be represented into a tree structure. So now, on the basis of us knowing that the players will choose the best decision that will result in them having the best possible outcome, then that means we can predict the final outcome of the game, because we know that players will always choose the best decision. So this type of search is called a minimax game search, where we are going to find the final outcome of the game based on the premise that the players are intelligent agents. Okay? So for here, I have an example of a game modeled into a tree structure. So in this tree structure, we can see at the very root of the tree, we have one node here representing the turn of the player trying to maximize the cost. So this is player 1. And on the next layer, since the player 1 made their turn, it's now time for player 2 to make their turn. Okay? Tapos, sa pinaka-dulong node, and the very last node, we see here the possible costs, or the possible values, the final values of the game. So there are 9 possible final values of the game depending on the decisions of player 1 and player 2. So now, we assume that they are going to choose what is best for them. For this player right here, on the second layer, they are trying to minimize the cost. So that means that they are always going to pick the route that gives them the least possible cost. Hence, in this part, you can see here that player 2 pick the node that gives an outcome of 4. And we can also see that on the next steps of the minimax game search. So in this one, player 2 picks the outcome of 3, and on the last node, the very third node in the second layer, player 2 picks the outcome resulting in a value of 3. Finally, here on player 1's turn, player 1 has this knowledge that player 2 will always pick the least possible cost. So knowing this knowledge that player 2 will pick 4 here, will pick 3 here, and will pick 3 here, he now has to pick the greatest possible cost that he can get with that information. So he wouldn't pick this one, the node going to a possible value of 15, because he knows that player 2 will just pick the outcome resulting to 3. Therefore, he plays it safe and picks the outcome that will eventually result in 4. And that is our final state of the game according to the minimax game search. So as we see here, we had to check each and every node for their values before determining the final state of the game. However, we do not need to do that, right? If we assume that the players will choose the best possible decision, then we can also not explore certain nodes. So this process is called alpha-beta pruning. So this is done together with the minimax game search in order to make the minimax game search even more efficient by not checking other nodes at all. So how does it work? So first here in the first node of the second layer, we first have to check what player 2 will pick. So basically same steps pa din compared to minimax game search. So we explore each of the nodes because we're not yet sure which one's the least possible value. Only once we've explored all the nodes will we see possible that player 2 will most probably pick 4, considering that player 2 always picks the least possible cost. So now with that information, player 1 can now say, okay, I know that player 2 is going to pick a possible value of 4. I want to pick the greatest possible value. Therefore, given the circumstances of what player 2 is going to choose, I can only expect a value that is 4 or greater. So now after that, we explore the second node of the second layer, and we see that min encounters a value of 3. So because player 2 encounters a value of 3, player 1 is now going to say, okay, this node here, the largest possible value I can get is a 3. Yun yung pinakamataas na value ko makukuha dito. At yun yung pinakamataas na value ko na makukuha if I choose to explore the second node. Therefore, I do not need to check any of the values anymore on the other nodes because I know that I will never get higher than 3 in this node. So therefore, these two nodes that are connected to the second node in the second layer are pruned because player 1 will never choose that specific node. Okay? Finally, for here, in the last node of the second layer, you can see here that player 2 will encounter a 15, and then a 6, and then a 3. So for each of the steps, player 1 is going to say, okay, I see a 15 here. Probably, there might be a 15 here, so I might choose that. Let's see the other nodes. I see a 6 here, so maybe that player 2 is going to say, that's my minimum for now. And player 1 will say, okay, I might choose that column, that node to explore later on. And then player 2 sees a 3 here and says, okay, the minimum value I can get is 3. Player 1 will see this, and player 1 will see this, and they will say, oh, so I encountered a 3 here. However, I've already seen a 4 on the first node here. Therefore, I do not need to explore the third node at the second layer. My decision is going to be the first node at the second layer instead. So that results in the same routing, in the same final outcome that we have discussed earlier. However, we did not need to view these two nodes down at the bottom here, the ones that are corresponding to 5 and 7 supposedly. So that is the basic, that's the gist of how alpha beta pruning works. So thank you for listening, and we hope that you have found our videos useful. Once again, I am Aaron Gabriel de Chasa, and thank you for listening.